homework instead. It'll be 10 minutes of me talking really fast, and then you have to go and look it up yourselves.
Take it away, Robert. You are being recorded.
Cool. Okay, right. So 2-ish years ago, there was an issue talking about how the branches API gets notably worse under load. So it gets exponentially worse the more requests that go to it. And it was causing an awful lot of like garbage collection problems, all sorts of things. I'm not going to go deeply into the issue, but at some point in it, I figured out that it was coming from a method on the repository called merged branch names. And so what this was doing was returning a list of branches that have been merged, or more specifically, you could request the status of a set of branches. So you'd pass a list of the branch names to this method, and it would return back whether they had been merged or not. So that's all it really did. But it did it it's very intense. It has to go through a lot of the Git repository history in order to figure this out, to know whether a branch has been merged, all this sort of stuff. It wasn't actually cached. And so as it gets hit more and more, it does more and more file system reads, and it gets slower and slower and slower. So eventually I sort of figured that out. When I debug things, and you can go through most issues that I've worked on, I just write like a list of comments as I'm trying to figure it out. So you can usually see how I got to the like the conclusion that I did. Although sometimes there's just like a bit where I've missed it, and it's like, oh yes, it was this, and there's just like a huge gap in knowledge. But anyway, so needed to add a cache to this, but it's quite weird because of the fact that you can't really cache the whole thing, because for the GitLab repository, we have hundreds of thousands of merged branches, something absolutely insane. So you don't want to cache that whole thing every time, because for each repository, it would be enormous. And you'd probably have to either cache it individually for every single branch. So every single branch name is cached, saying that it's merged somewhere. And either you'd have to update that list, or you'd have to delete the whole list every time. So it ended up in a fairly interesting solution. And I did it through 2 merge requests. So the first one sort of shows the structure of where I added the caching, and then the second one is where it gets really interesting. I say really interesting, slightly more interesting. And it uses a really weird cache that we only use in this area. So there's some basic sort of setup here in the repository model. But mostly what we're looking at is here. So this is where there's the merge branch names. You can see before it just delegated it straight to the repository. So there was no caching. There was nothing going on there. And instead, I'm just going to move this over here. I think that should show up better. So yeah. So to start with, I added a basic cache that did it by sort of just serializing a hash of like the names that you'd asked for. So you pass it the branch names that you want to know the status of, and then it would return those as a hash instead, or more specifically a set, apparently, that would say this name true, false, as to whether it was merged. And so for this first version of it, you can see that it just reads straight from the Rails cache. And when it writes them, it just writes here. It serializes a hash into a single key in the Rails cache. So it doesn't even matter what backend store it is. It's just a serialized hash. So you can't do anything with that hash. It's just a single cache value. Every time the repository is updated, this key would get deleted, because we can't update the individual entries in it to say this new branch is cached, but you don't need to like delete all the other ones, because they're still they're still merged, like their status is the same as it was before, but you can't do that. So that was just the initial version to kind of get a rough idea of it. But it then very quickly changed to this one. So this is where it gets a bit big. I will go through this. So there's only a mild update to the merged branch names after that, but what this instead uses is something called a hash key in Redis. So we use Redis as our backend cache. It's probably less. Oh, it's certainly harder to scale than using memcached, which is what I would normally use, but it does give you some interesting features. And one of the ones that you can do is you can store structured data in Redis. And this is one of the rare instances where it actually makes sense to do that, because we need that. We don't just want a list of merged branches or not merged branches. What we want is a list of the branches that we've supplied it and whether they're merged or not. It's a really, really niche use case. So this was an awful lot of code to solve one specific problem. So this changes it over. I'm gesturing at the screen with my hand, but that's not very useful. I'll try and gesture with the mouse. So in this method, we're only really changing one thing here, and that uses this method. So I'll come back to this in a minute. And it then just returns the same data as it was before from that previous cache implementation, but it does something using this Redis Boolean method too. So I'll explain both of those as they were both added, and that's actually a useful class if you ever do any Redis stuff. That's quite handy. So the main implementation of it uses this thing called cache fetch and add missing. So this is written into the class repository hash cache, which I could probably have named better. It's quite large, but most of it makes sense to just sort of read through. So you've got, in an initializer, a cache key method, delete method, a key, test if something exists in it, a way of reading a set of keys, so getting just the values of specific things that you want out of the hash, a write method. You can kind of like ignore a lot of these. Yes, Sean.
What's the with method there? With do Redis.
So that uses that's sort of using the connection pooling thing, I think. So it takes a Redis connection out of a connection pool and uses that. The pipelining bit is then doing what is essentially a transaction, like a database transaction with Redis. So it's doing a load of these together. So this looks inefficient because you're doing like a set per item in the hash, but actually it's just doing them all in one transaction. So it's actually very fast. It's not really the same as a transaction in a database, but it's worth looking up, reading how Redis pipelining works, because it does have some oddities, but if you think of it like it works that way, it kind of works that way.
Okay.
So that's how the write method works. But then the interesting one is fetch and add missing. So this is where the real work happens. And this is the most efficient I could make it. So what it does is you give it a list of keys that you want to look up. So you're looking for these branch names and you want to know their status. So what it will do is it will read those keys from the hash stored in Redis. For any that it can't find inside the hash, it will then call a block only once, so not per key, but it will, like for all the ones it can't find, it stores them in an array, calls a block with that array, and then uses the result of that block to populate the cache, but also merges the results with the stuff it did get from the cache and returns it. So what you can do is you pass it a set of keys and you will get data back that looks exactly the same as if you just read it off the disk, but some of them can be from the cache and some of them can not be from the cache. And it will look the same, but at the same time, the ones that weren't in the cache are now in the cache. They've been added as part of that process. So when you're looking at the fetch and add missing method, I think it's largely explanatory. I wrote a lot of comments because I figured I wouldn't even remember how this works 2 years down the line. And I was correct. I don't really remember how some of it works. But that's essentially what it does. So you can see it most easily in how this is called here. So where you've got, I opened it up in there. Here we go. So here's that method where it's calling fetch and add missing. Oh, God. And then calling this block. So it calls the block with the missing branch names. These are the ones that aren't in the cache. It then fetches that data from the raw repository. And then it creates, or it returns a hash. So the hash is passed as a value as well, and you just update it with what you want. So it doesn't care about the return value. You're directly updating that block argument. And so for each of the missing branch names, it then sets the value in that hash using this Boolean helper. And so the Boolean helper just, how do I best describe it? If you store anything in Redis, it's stored as a string. If you store a Boolean value, so true or false, it's stored as the words true and false, which actually means that if you have a lot of false values, you use very slightly more memory because it's one letter longer, which is a really stupid thing to worry about, but it kind of makes sense. So the Redis Boolean class is the exact same size for both values. So true values and false values. It just basically does like an underscore b:1 or 0, I think. And that's basically all it does. We'll have a quick look at it. Yeah, here you go. So it's probably the most boring class in the entire application. It's really, really uninteresting, but it is quite useful because it does allow you to consistently just store Boolean values, and it kind of works all right. So yeah, essentially in that fetch and add missing, it's then returned that data back to the Redis cache, and it gets updated. Where was I? So we'll go through exactly what it does. So first it reads the members for the ones that it can't find. So where it's got no return result, it just takes the keys back. It doesn't need the nil value. If there are any missing ones, it runs the block with the empty hash and the missing array of keys. It does some standardization of the hash. It effectively just makes sure that everything's converted to strings, because it will be converted to strings at some point. But there could be a difference between the cache keys and values and the non-cached ones by having like symbol keys instead of string keys. So it just converts everything to strings. So they're all exactly the same. It then writes the new values only back into the cache. So it's just updating the cache value with these new values. It doesn't clear the existing cache, because the size of this is actually shown up in some performance reports. This can be like 10, 20,000 hash key entries large. And it showed up on a performance thing, and they're like, oh, this is really bad. You know, we should improve this. It's like, this is the improvement. This is notably better than it was before. Those were just being read off the disk. So it's a bit better at least. And then at the end, all it does is merge those values. So you've got the uncached ones that are being merged with the cached ones you had before, write some metrics, and then it returns it. And so that's effectively all it does. And the performance difference in it, I think, shows up in this graph. Here you go. So, yeah, you can see towards the tail end of the graph where it just completely drops off. So it effectively standardizes the performance to a base slowness. I wouldn't say it's fast. It's just consistently slow now, not spiky slow. It used to be really bad, like multiple seconds, and then it's just gone down a lot. So let's see if we've got it keeps going on a bit longer. And I thought we had an additional graph of that, but I might not know where it is. But yes, essentially everything's under 1 second now. So that's how it improved it, at least. And as far as I know, this has never been a useful piece of code for anything else ever since. It's only useful for this circumstance. If anyone does think of a use case, great, because I put a lot of effort into it and I've only used it once and it feels a bit stupid. So does anyone have any questions? Because I think that's kind of it. Yes, Sean.
Okay, so when we say branches, you mean unmerged branches or merged and unmerged branches together?
Both. Yes. So it's essentially looking for the status of a branch, whether that branch is merged or not. So and telling whether it's merged or not, it requires going through the Git history, I believe.
Okay.
Yeah.
And then once we delete a branch, I've always noticed we've got this feature, undelete the branch. So once we delete a branch, does that fall out? It disappears out of this.
So there is an expiry time on this cache of like a couple of weeks, but in Redis you can't expire individual hash keys. You can only expire the entire hash set.
Right.
But the entire hash set does get deleted, so it gets cleared entirely in certain events. You can see some of it so here in the expire branches cache, this gets called on certain events. I can't entirely remember in which way it gets called. I don't think I've changed in that one. So it's just changed in the first one. So essentially it's added into this clearer. And I think it gets cleared on certain types of pushes. So like a force push or something like that. But it doesn't get cleared like when someone just merges a branch, if that makes sense. I think there are a few situations in which it can get cleared, but yeah, basically we just don't really care about deleted branches because you're probably not going to be up like querying whether it's merged or not anyway, because it doesn't exist anymore. So it will eventually disappear. And because it's not used as a whole set, at no point does this get used to return all of the data it has. It's only used for checking against what it knows. So a set of branches you want to know the status of, it returns the status of those branches. It doesn't care about returning everything.
And because we're passing the list of branches, then we don't need to also worry about user ID or any access.
There's no access stuff on this because there wasn't before. It was querying the repository just straight away with nothing.
You can see all branches anyway.
Yeah.
Cool.
What happens if a branch was reverted? Like a merge was reverted?
So I believe that's one of the situations where it will run that expire branches cache method. So
delete the cache.
Yeah, I did know this 2 years ago, the situations in which it gets called, but yeah, I'm a bit fuzzy on it now.
But that's so that's on a kind of organizational level, is it that gets run?
Yeah, I don't actually know. I think if you do reverse it, I've got a feeling it does just expire the entire cache, which is quite expensive because this can be a really big cache. but
Oh,
the
the whole cache, like, so if there's any reverts across the whole cache.
it would only reverts. It would only delete certain caches. So probably the branches cache. Yeah. So it would delete the entire key and all of its values. So it does end up causing quite a lot of traffic in and out of the cache. But because this cache is sort of added to, it's not like the next time someone checks for the merge status of a branch, it fetches the whole list again and rebuilds the cache. It just adds that individual record. It's quite a sort of a gentle cache to repopulate. It sort of builds up over time, gets to a certain size, gets deleted. It results in quite a lot of traffic in and out of the cache, but it's not as bad as like loading a huge blob of data into the cache each time, which is what the first iteration, this one, before the hash cache, was doing. So it would just cache huge blocks each time. And so that is an improvement in terms of the impact it has on the cache.
Because we're driving what goes into the cache based on need, right?
Yeah.
Yeah.
Patrick, do you have a question?
Yeah. So I actually have some question about the original problem. I know you wanted to go over it pretty quickly. So the original problem was not on the database level. It was also on the cache level because we were merging use strings, or it was something else.
So on the actual issue itself, the performance issue. So yeah, what the problem was with this was that so it's not at the database level that the problem exists, or I mean, it sort of is if you count Git as a database, but effectively the slowdown here is that it's hitting the hard disk every time to read the information back. So I don't know if from Git, so every single request for merged branch status made a request on disk, which is by far and away the slowest request that we can make. I'm just seeing if there's any other debugging I've put in this. Yeah, so there was this bit of info here about which methods were taking a long time. So this is sort of starts showing how it goes down the stack trace to sort of find bits. But yeah, effectively what it was doing was making a call to this to the ref service thing. So this is a wrapper to the to our Gitly client, to our Git client, and that was the one that's being hit all the time. That's
okay.
Yeah. Igor, do you have a question as well?
Yeah, just to the previous topic. So do I understand it correctly? So that this merged branches names request, its performance depends on the number of branches, yeah, that we pass in there. Yeah. So so actually this merge request improves that we doing this request only for missing branches. Yeah. So we just reduce the payload. Yeah. Do I understand it correctly?
Yes. So yeah, if you, because the problem you'd have otherwise is that if you were making a request to the cache first and saying, I want the status of these, but it only has them installed in one value. If it wasn't up to date, then you would have to read all of them from the Git repository. Whereas this one, because it allows you to do a partial read, like it knows some of the information and then it fetches just the missing stuff, and it fetches the missing stuff quite efficiently because it makes only a single request. It does work quite effectively in that regard. But yeah, it's such a niche use of this. I've not actually found another use for doing like a partial cache read, like in the application, where you just sort of like you're adding to it little bit by little bit. I'd be really interested to know if there are any, because it was quite a good performance improvement without a lot of the side effects of heavy caching.
Maybe we're doing something similar for highlight diffs. I think we store a hash, I guess. So it's like a key is a file name and value is a highlighted diff for this exactly this file. So if additional file appears to be cached, so we just add the value to the hash. So we don't rewrite the whole cache.
Yeah, it'd be interesting to see. The only downside really to using hash things is that you can't expire individual keys in it. I mean, you can delete them, so you can manually delete them, but you can't set a time to live on it for when that hash value should expire. You can only expire the whole thing. So in the implementation of it, it's a little bit dumb. Where is it? Yes. So every time it adds a new key, a new value, it updates the expiry. So it actually does this in a loop. So it does it every single time for the whole key. But because it's in a pipeline, it kind of doesn't matter that it does so much. It could potentially be optimized. I think you only need to do it once right at the end. I don't know if we improve that later on, but yeah, essentially because you can't delete the individual value, that's kind of a shame, and it might limit it in some other implementations, but it's partially a limit on how the Redis hashes work. We did have some optimizations later on tied to this, but also there's actually a very similar class that's repository, it's array caching instead. So it's caching a list of things without values. And that's got a few areas that are kind of shared with this, but it doesn't have that really weird partial update system. That's as far as I know, the only place we do that.
And if we have half a minute, I have a quick story about Redis pipeline that I want to share. Just a quick note regarding Redis pipeline. Yeah, so it's like groups a lot of calls and performs like a single round trip to Redis and saves us like we save a lot of time on the round trips. Yeah, we don't need to perform a round trip for every Redis call. And actually for the set requests, yeah, when we don't need the data, it's pretty straightforward, yeah, that we just perform the request and don't care about the results. But when we want get request, yeah, it's like when we want get data from Redis, the data is actually grouped, but we need to wait until all requests are performed, yeah, until the end of the round trip in order to get some data. So this Redis pipeline, it's actually wraps the data in the future class. And then we need to call like result in order to receive the data, yeah, that was like lazily loaded. But yeah, my story is about feature flags. So that I used a feature flag inside pipeline block. And since our feature flags like values, they are stored in the Redis database, that feature, when the feature flag value was evaluated, it was like a future, because sorry, I can't explain it, but yeah, since it was used in the pipeline, and we don't call like explicitly result method on the feature flag, we received like a future wrapper, not the value of the feature flag. And the strange point was that our unit test haven't caught it because we stopped the values of the feature flag to avoid doing Redis calls and tests. So they were only reproduced on the QA tests. So that was my story. And yeah, that's all. Sorry for interruption.
That's a more interesting feature flag problem than even I've had. The worst ones I've had were ones where if you use a feature flag call too early in the Rails initialization stack, it attempts to perform it before any of the databases exist. And I found this out after deploying to production twice, the JSON wrapper changes that I did as well, again, like 2 years ago. And yeah, it breaks everything. It's so frustrating as well. And it doesn't show up locally properly because the GDK reloaded differently, or it loaded things in a different order at the time. And yeah, I don't like debugging feature flag problems. That would make an interesting future one. I'll do the JSON one at some point, because I think there's a log of me breaking production like 3 times with that. And it's actually still relevant. Like the things it does are quite relevant, and still a little bit weird. Cool. Is there anything else? Any other questions on it?
That was really great, Robert. Thanks so much. Some pretty interesting code there. And just for your information, you know, we're probably going to be doing a lot more work on performance style stuff coming up soon. So yeah, maybe there will be some way to dust this code off and reuse it. Who knows?
I went through a period of writing really elaborate classes that only get used for one very specific thing.
I did have one last final question, actually. So when we saw those huge spikes, that's disk, right? That's going to Git on disk.
Yeah.
Okay, right.
Yeah, there's been a few performance issues like that. I think we've now covered most of them, but obviously new ones turn up over time. But there were always like little weird ones like that. One of the strangest ones was in how avatars were fetched, and that was doing Git calls or something. I don't know, something was really weird with that, and it was on a page that literally no one uses. I'll go into that one at some point. That one's quite fun. Fixing a performance issue that was one of my best fixes, and it's on a page literally no one cares about or uses. I didn't even know it existed. I didn't even know we owned it. So it's not the best one.
And one quick note about your classes, Robert. Yeah, the documentation is pretty cool. Yeah, I think they are the most documented places in our code base. As you mentioned, they are not reused really often.
I went through a period of just writing yardoc stuff in every file, even though I was explicitly told not to. And I said, I'm just going to ignore that. And so I wrote it anyway. And I don't regret it, because even if we don't generate yard documentation, when you go back and read the code, it does help you kind of get a rough idea of what was going on.
Yeah, and also, yeah, just for future reference for whoever's presenting coming up, we don't have to have, we were talking about an MR that we just worked on. It can be something that was done some time ago. And I think this is a great example of that, because first of all, it's obviously still highly relevant, but yeah, some super interesting code. And it's good to sometimes dust things off that you've looked at or worked on a couple of years ago, for you know, for who that applies to. And yeah, thanks a lot, Robert. That was great. I'll stop the recording.